Calculus video 6, a quick example, two examples of some limits. So I start here with a graph of a function, and it's a function because it passes the vertical line test, even at 3 here, because there's only one value at 3. And the first limit says the limit as x approaches 0 of the function. So if I look at x equals 0 and I go up to the function, I can see it's 3 there. You can see it from the left, it comes into 3, and from the right, it comes into 3. So the answer to this one is equals 3. I suppose to make it look pretty, I could have it a little closer. On the second one, you'll see it says the limit as x approaches 3 from the negative side. So I find x equals 3 here, go up, and I see it comes from the left-hand side. It's coming in up here. It's coming into 4. Then the next limit keeps on rolling. It says what's the limit as x approaches 3 from the right-hand side, the positive side. So I look here, and it comes into 2. Now this is a classic case. The left hand's 4, the right hand's 2. The limit then does not exist. And the value itself at f of 3 should not be confused. It is simply that the dot value, which in this case is the 0.33. Now, I have another example. I'll pause for a second and get to it. Again, I have a function here. It passes the vertical line test everywhere. It's a piecewise function. It has a curve to a removable discontinuity here. Curves down to a jump discontinuity. Curves up to another removable here at 2. And then it comes through into a function that varies. It looks like a sine function up and down, but it passes the vertical line test. And then comes up here to this last function. And I'm saying here at 5, there is a value here of 4. Alright, so I'm going to pause. I'm just going to put up all the answers at once. We're going to work left to right, and I'll go through y. Alright, working through the values rather quickly. The first 3, a, b, and c, are all talking about the limit at x equals negative 3. The first is from the left-hand side, the second is from the right-hand side, and the third is just the limit. As you approach from the left-hand side, it comes up to, and it looks like here, 1, 2, 3, 4. From the right-hand side, as you approach, it comes to 4. Therefore, the left hand and the right hand are equal. Therefore, the limit approaches 4 also. But there is no point, so letter D does not exist. It is not in the domain. It is an open removable discontinuity. At 0 for E and F here, the left-hand side approaches 1. The right-hand side approaches negative 1. Again, the left hand and the right hand have to be equal for letter G, so the limit as x approaches 0 of h of x does not exist. Again, h of 0 is asking what value of y happens at 0, and it is here at the solid dot 1. This is a point 0, 1. The limit as x approaches 2, the left hand and the right hand both approach the value of 2. And h of 2, again, if I look for a value here, it has no value. It's a removable discontinuity. It does not exist. Again, based on how the graph reads, I'm saying that this is a function, and the limit comes in from the left-hand side and the right-hand side, both to the value here of 4. And that's k and l. Thus, the limit as x approaches 5 of h of x would also be 4. Again, limits just take practice. Keep on trying and keep on going. Video 6.